Okay, let us review some concepts for the first portion of the uh, class. So when we talk about kinematics, we talk about a rigid system. So could be any geometry, but the main thing to know is that the system is going to behave as a rigid body, meaning that it's not going to have internal forces. Everything is going to be external. So you can picture, say, a box is moving um, in a certain direction and it has a collision with another box. When the collision happens, there's going to be a deformation, obviously, and depending on how much energy there is, and the materials, if it's a cardboard box instead of a crate, there's going to be deformation. And this will have stress and strain and internal forces that we're not going to consider in dynamics. In dynamics, everything is a rigid body, and we only care about external forces, such as gravity and impulse or forces to have them move or stay at equilibrium. If this is the other thing, if the system stays at equilibrium, the force is equal to zero. That is going to be a static system. Static. We talked about this before. If the forces are not equal to zero, then we're going to have a dynamic system. And in that case, we have to know if it's going to be a rectilinear dynamic system, or which we're going to talk about later, if it's a curvilinear system. Linear system. All right. Okay. So talking about a rectilinear system, the kinematics. The kinematics is the study of the dynamics of the mass in the system. We know that the force can be found by the mass of the system times the acceleration. So if they give you the mass in kilograms and they ask you what is the force on the moon, then you simply need to know, what you have to ask, what is the acceleration of the moon. If it's on here on Earth, then you use 9.81 meters per second as a general constant, because you can be much more detailed and have different gravity constants depending on where you are. But this is a good approximation to a general value. Okay. Then if they ask you to find the path of a particle, they give you the function for it as a function of, say, time, and it's a constant times the time at a certain power. It's not a line, it's a curve, it's a polynomial expression. Then you simply find the position at time equals different values, equals 1, 2, 3, etc. Okay, so if they ask you what is the position of the particle at t equals 5, then this is the function. You simply put 5 on your time and evaluate the function. If they ask you what is the velocity, then we know that the derivative of my displacement with respect to time is my velocity. Okay, so this will be n times a t and minus 1. All right, and then v as a function of t is equal to that expression, which you simply have to evaluate at whatever time they give you. So at t equals 10, then you evaluate. On the other hand, if they give you the acceleration is equal to acceleration of, oh, by the way, this is just a constant, it's not acceleration. But if they give you acceleration as a function of time, it's equal to n t So like say, for example, let's do this better. Acceleration as a function of time is equal to 5t plus 2. Just making up a function here as a straight line, intercept of 2. And they ask you what is the velocity. So the velocity is integrating the acceleration with respect to time. So you simply have to integrate this function. Okay, so you know how to integrate, and evaluate at whatever time they're asking you. So this is the acceleration function, and we have to find they ask you, the question is what is the velocity at t equals 2 seconds. Okay, by the way, make sure that this function is given in seconds or milliseconds, because if this function is given in seconds and they're asking you for 2 milliseconds, then you have to divide by 1,000. So it's depending if it's seconds or milliseconds. But t equals 2 seconds. Then you integrate because you want to find the velocity and evaluate 2. As simple as that. If you want to find the displacement, then you have to integrate again. And if they ask you for t equals 3 seconds, then you simply have to do that part. Okay, so very simple. So that's the first type of problem. If they give you the function and they ask you to evaluate displacement, velocity, acceleration, very simple. Just integrate or differentiate. So from velocity, if you want to go to displacement, or if you want to go to acceleration, that's the route. If you want to go to velocity, you have to differentiate. And from velocity, if you want to go to acceleration, you have to differentiate velocity, find the derivative. If you want to find the velocity from acceleration, you have to integrate. And if you want to find the displacement from velocity, you have to integrate velocity. Okay, this is the integral. So very simple. That's the very first thing, and it's a typical problem in dynamics. Okay, the second one, also in rectilinear concepts, is if they give you a system moving, then remember that you always have a coordinate system of reference. And F summation of forces in X equals F equals, let's do it again, summation of forces in X and summation of forces in Y. If it's 0, then the system is in equilibrium. If it's not 0, it's equal to an acceleration. So F equals the mass times the acceleration. And remember, acceleration is a vector, so in X and in Y. So in this case, if there's acceleration in X, then you have to consider this part. If there's no gravity affecting the system, it's already on a plane moving, then this could be 0. So you set up your equations, you free body diagram. If there's friction, remember that the friction coefficient is a percentage of the force that takes to move. So if it's 0.1, then that is going to be multiplied times your normal. So we have plenty of examples like this, statics and dynamics. Force of friction is going to be your friction coefficient times the normal force, which is normal force is going to be in your y-axis. And this is a percentage, like 0.1, this is 10% of the force on your normal. Okay, so this is simply a coefficient that you multiply times your normal force. Now, the only confusing part here is if they give you a plane that is inclined. In that case, my recommendation is to have your coordinate system on the plane with inclination, because then it's very straightforward to have your normal and forces with respect to the angle. Okay, if you notice, this right here is 90, and say this right here is alpha. Okay, so if you build the triangle right here, then you're gonna see that this is gonna be alpha. Sorry, this is gonna be theta, right here, theta. We said that this is going to be 90, and this is going to be alpha. So don't let it confuse you. This whole thing right here, it's tough to see, it's difficult to see. This whole thing right here is 90. So let me draw it again. You have that, and that is 90 because that is basically our coordinate system. It has to be orthogonal, 90 degrees, right? And we're choosing this positive and this is negative. So this is positive y, negative y. And then we have a box that is sliding on this angle. Typically, if they give you the angle elsewhere, just be careful, but typically, they're going to give you the angle right here. Theta or alpha, whatever they give you. And what you need is a system of reference that gives you information for your forces. So if you notice, there's a normal vector here, right? And then there is a component. Gravity is always going to be vertical in the absolute coordinate system. So that's the confusion. Even though we chose an arbitrary system, gravity is going to be pointing down. Okay, so if you take this part right here, this is exactly what I was mentioning over here. So we can name this angle right here alpha, and we know that alpha plus theta equals 90. And this is our 90 right here. Okay, so in that case, if we move that triangle, if we try to find the triangle here, this is going to still be, this is a straight line. Okay. That's why it's confusing, because that doesn't look like it's a straight line. Straight line, okay. And that part right here is going to be theta, and this part right here is going to be alpha. So that's why when you do your summation of forces in x and summation of forces in y, you need to use this cosine of theta for your y and sine of theta for your x. Okay. All right. And then everything else is the same. So the forces here, there's going to be friction, and then the normal. We know the force of friction is going to be the friction coefficient times the normal, but of course the normal is going to have some components in x and some components in y. So really this is the only difficult part. Once you do your free body diagram, you have half of the problem already solved. So we saw also average velocities and average acceleration. In that case, it's just because it's very useful, simply because you go from point A, which say is Austin, and you go to point B, which is Houston, and so for 1 hour you go at 70 miles per hour. Then for 2 hours you go this is the simplest problem I can think of. You go at 60 miles per hour, and then for another hour, let's say that's traffic, and you went um, and again this is average. So for some portion you went at 80, and some from another portion you went at 40. Okay, so 80 plus 40 divided by 2 equals 60. 120 divided by 2. So this one is also at 60 miles per hour. So let's say right here you went at 80 miles per hour. Okay, so see, I'm already taking averages, and averages is just very convenient. So what we have is that in this case, though, if it was 1 hour and 1 hour and 1 hour, it will be very simple. If this is 1 hour, it will be just 70 plus 80 plus 60 divided by 3, right? And it's very simple because that would be 60 and 80 is 140, and then 140 and 70 is 210 miles per hour divided by 3 paths or 3 ranges is equal to 70 miles per hour. And that is if we only had a 3-hour trip. If it was 2 hours at 80 miles per hour, it would be 70 plus 80 plus 80 plus 60 divided by 4. Okay, and that is 80 and 80 is 160. 160 plus 60 is 220, plus 70 is 290 divided by 4, which is around 75.5, approximately 76 miles per hour, or 75 point something, right? 0.5, whatever this number is. You can use a calculator. So we're going, and this first trip was 3 hours, and we're going at 70 miles per hour. The second trip is 4 hours, going at 75 and change miles per hour.